Hey everybody, we're getting ready to do exponential functions today. So exponential functions are pretty easy. We have the equation y equals a times b raised to the x power. Not a lot of variables in here that we need to remember what pieces are, but a is initial value, also known as your y-intercept here. B is the common ratio, and a common ratio means how are the y's changing, okay? Change can either happen in a positive or a negative way. If it's positive, it's growth. So you'll see here we go. Or it's changing in a way that is not a positive change. Something's getting smaller over time. And you'll see here is the second one where you can have the decay. And you see as it goes down over time. Notice it starts off as close to this x-axis as it can be and goes up for growth. And reverse for decay. It starts up high and starts to go low and gets as close to the x-axis, but it never actually crosses. And of course, you can see the opposite, the negative functions, if you flip them or reverse them over that x-axis for you. Okay. Again, note a can never be 0, and b can never equal 1. It has to be greater than 0. Okay. You're going to notice that b as your growth factor is going to be larger than 1. Or greater than 0. If it's in between that 0 and 1, it's decay, meaning it's less than 1 but greater than 0. And if it is larger than 1, then it's growth. Let's see how these start to work. First thing you're going to do with exponentials is you're going to start to see a lot of different ways to identify them. They want to know, how do we even do this? What do we have here? We have tables of values. And when we look at these tables of values, what we want to do is we want to make sure that do this comparison. What's happening to the x's and the y's over time? So as your x's increase by 1, what is happening to the y's? Well, look, it goes from -3 to -9 to 27, -27, -81. Something's happening. If you were to take -9, and let's say if we just divide these, this is how you find a common ratio, which is what we're dealing with exponentials. Divide your second y by your first y, and we end up with 3. Right? Do it again. -27 divided by -9 equals 3. And so on. As you keep going down over and over again, you're going to notice that you have a common ratio here. And a common ratio is 3. They're not adding 3 every time. They're multiplying by 3 each time. So when it's a multiple, it's a common ratio. And you can say, hey, this one is exponential. It's an exponential function. Let's take a look at this one. What's happening to this one every time? Well, from here to here, they're adding 5. From here to here, they're adding 5. From here to here, they're adding 5. Notice it's plus 5, plus 5. This is a common difference. So we know that this one has a common difference, meaning there's a number that's being added or subtracted each time, of 5. Since you have a common rate of change, a constant rate of change, this is linear. Imagine all this blast from the past. As we get towards the end of algebra, you start to see a lot of stuff we've done starts to come into play. Let's look at these, -2, -1, 0, 1. And we've got this weird thing going on. The y's are large, they're getting smaller, and then all of a sudden they start to get bigger. Kind of like our U-shaped graphs, our quadratics. Quadratic. And there is no constant change. The change is all over the place on this. You can't discern a constant rate of change from just looking at that. Okay, those are hints and tricks. The other thing they're going to want us to do is they're going to want us to try to write equations for these. So you have to remember A, initial value, y-intercept. Look at the table of values. When x is 0, for x equals -b plus or minus the square root of b squared, minus 4ac over 2a. We were finding x-intercepts. We always had it set equal to 0. Okay? we have all these things that we've done all year long are starting to play into our account. When your x is 0, we want to figure out where is our y-intercept. When the y is 0, we needed to figure out the x-intercept. So the quadratic equation was always setting equal to 0 because we were trying to find the x-intercepts. Now, look at the reverse. We want those y-intercepts. So when you want to find a y-intercept, your x is 0. So look, x is 0 right here. So that means A, our initial value, is equal to the y-intercept. Which is equal to 5. And now all you have to do is divide these, divide these, divide these. What's happening? Well, 20 divided by 5 is 4. 80 divided by 20 is 4. 320 divided by 80 is 4. So your common ratio is equal, which is B, is equal to 4. And you can write your equation. Y is equal to 5 times 4 raised to the power of x. That's simple from a table of values, especially when they give you this right here. All right. The next way they can do it is, what if they give us 2 points? And this works all the time. So when you have 2 points, you want to set up a system. You want to set up a system of equations. System of exponential equations. All right, so what do we do here? Okay, so we have, there's our y. 7 is equal to 0. Oops. It's equal to A times B, and our x is the 0 up here. Do it again. 224 is equal to A times B raised to the power of 5. Right? So we go to anything raised to the power of 0 is 1. So that's just A. So A is equal to 7. So then we can use the law of substitution to plug it in there. 224 equals 7 times B raised to the power of 5. Now we need to solve for B. So divide by 7. Divide by 7. 32 is equal to B raised to the power of 5. And this is when we will have to use a new button in our calculator. It's the nth root button. So in your calculator, you're going to want to type 32. You hit the shift button and find your nth root button, and then you type 5. So in your calculator, you'll hit that button, the nth root button, just like this, and you should end up with 2. All right, so we know that when we take the 5th root of both sides, right? The 5th root cancels the 5. When you take the 5th root of this, you have 2 is equal to B. Now you have your A, you have your B. We're ready to write our equation. Y is equal to, well, we said A was 7 times 2 raised to the power of x. Just like that. Remember, we're always trying to follow this format for these equations. A is your initial value or your y-intercept. B is your common factor, which could be growth or decay. And your exponent is actually your input. So anytime they ask you, hey, can you identify which of the following equations is an input, you can see it right there. Your x will be your exponent. All right, that's it for today. Get out there, finish that homework.
Recording your lesson?
Yes.
Do you record a lesson every day?
I record every lesson I have in algebra is all recorded. And if I change one, then I redo the video. But it's all there. It's all on my YouTube channel.
Yeah. All right. So, anyways, the